Hey guys, it's Little Black Belt here, and welcome to the next C++ for Beginners tutorial. In today's tutorial, we're going to be covering arithmetic operators within C++. So right here on the screen, I've got listed a few, actually all of the arithmetic operators in C++ that you'll be using. Some you use more than others, but you know, it really just depends on what you're doing. And a lot of these are the same as in math, you know. One notable thing here is this mod operator, which is a little interesting. I didn't even really think about it or know of it until I got into programming, you know. But it's basically like, you know, if you did long division back in, like, you know, elementary school, it's basically like taking the remainder from the division function. So we're going to be talking about these operators and implementing them in a demo today within C++. So let's get a new C++ file here. We're going to go to language, C++. Okay, and same as last time, we're going to include the IO stream. And there we go. We are also going to use the entire namespace, the entire standard namespace. And just like last time, we'll have our int main and return 0. If you're used to typing this is pretty basic. Sometimes you'll have more of these pound includes. Sometimes, actually, a lot of the time, you won't be including the whole standard namespace, but this is only the second video in the tutorial, so we will be using that until I get into more of the alternatives and just including bits and pieces from it. So, to get started with our arithmetic operators, we're going to have a couple different variables that we will declare right now. Declare and initialize, actually. So let's start with, we'll make an int a, and we'll give him 3. So you've just created a variable a and given it the variable 3, and even, or the number 3. And it's important to note that this right here, this equal sign, is actually an operator. It's known as the assignment operator because we're assigning a value to the variable a. This is not the same as the equals sign. I mean, it is the equal sign, but it's not. You can't think of it as you would like the equal sign in math, okay? Because in programming, it's different. There is an equals operator. It's a comparative operator, and it is in fact the double equal sign. But we will get into that later. Just know that this in C and most programming language is not a comparative operator or comparing a couple things. Like, for example, A equals B. We'd be comparing whether A is the same as B. No. You'd be assigning with this. So we'd say the value stored inside B gets the value, or sorry, the value in A becomes the value that was in B. So just know that there's a difference there. This is the assignment operator. And typically when I use it, if I was to speak this line, I'd say int a gets 3. Okay, so I typically use gets for this, but you can also say assigns or is assigned. You know, just know that this is not the equals operator. This is the assignment operator. Okay, so we will assign the value 3 to a, and we'll create another int b and give it 5. Okay, and then we'll experiment with a couple of these operators, and actually I'm making an int c as well, but I will not assign it a value. I'm just going to declare it. Okay? So, very simplest operators would probably be the plus and minus ones. So we're going to experiment with that now. Okay? So right now we've got this 3 and this 5, and if we wanted to add them together, then we could obviously just say a plus b, right? And that would, of course, yield 8, but we didn't store it in anything, you know, so it wouldn't really do much. If, let's say we want to store it inside the variable c, right? So c would get a plus b, and then, of course, 8 would be stored within c. So why don't we do that? We'll do c is assigned a plus b. Okay, so now c should have the value 8 because a was 3 and b was 5 and 3 plus 5 is 8. So that is a value that is stored in c. Okay, so if we see out that, and remember see out is just printing to the screen, we can say C is, and we'll say C. There's one thing sorry, that should be endl. There's one thing I forgot to mention in the last tutorial. Endl not only creates a new line like return does, the enter key on your keyboard, it also flushes the stream, okay? You probably won't know what that means right now, and so I'm not going to get into it right now. We'll get into it later. But just know that this not only returns and starts a new line, it also flushes the stream, okay? Because there's another way that you can do enter without flushing the stream, and that is doing this backslash n. This is a new line character. But I'm just going to use endl. It's very simple, and just know that that's not the only thing that it does, but you'll never really even see the effect of that unless in this sort of environment with simple variables and stuff like that. So, with this program now, it should output 8, right? Because 3 plus 5 is 8, and 8 is stored inside C, right? C has the value 8 stored inside it. So if we press F6 and execute this script here, and it's going to ask us to save our file, and we will call it, I don't know, add.cpp. Make sure you put the .cpp, otherwise it'll make it a .h file. Oh shoot. We want to save this to the desktop. Not bad. So, as you can see, it compiled just fine. We didn't get any problems, so now we can run it. And just like last time, go through the command prompt. We need to change directory to our desktop. And we can just simply run by add. Okay, and C is 8, right? Now, let's experiment with a different operator. We'll just switch it. We'll just make this a minus, right? So now what are we doing? We're doing 3 minus 5, right? That should be -2. So now when we say C is, and then we output the value in C, it should simply say -2. So let's, we have to do this again so that it saves it. Actually, what I'm going to do instead is just save. And then I should have kept my command line up and compiled straight from the command line, but we'll do that now. So we're going to compile add.cpp straight into the command line, alright? And so the way we do that is just type g++, that's our compiler, and then add.cpp, and that's telling it to compile add.cpp, and then using -o, that's going to allow us to name it, and we'll call it add, and that's going to override this executable with our new executable, which should have this change in it, that minus, right? There we go. And so now if we do add, C is -2 because we changed this operator to a minus sign. Okay, so I'm going to leave the command prompt up now so it's easier for me next time. And the next thing we can do is we'll try some multiplication. So we'll just put the asterisk in here, save again, and by now you probably get the point. I can actually just use the arrow keys to scroll up to my previous command, execute it, and now type add, and C is 15 because 3 times 5. Now here's where it gets a little bit trickier. Not super tricky, but it's a little strange. Okay, this division, because we're dealing with integers, which are whole values, say we divided 3 by 5, well, that'd be some decimal, right? 3 divided by 5. Well, I'll do it to show you, okay? So 3 divided by 5, we can pull up our calculator. I'm not sure exactly what decimal value that is because I'm not that great at math. It's 0.6. So looking at this for the first time, you might think that now C is going to be 0.6. In fact, that's not going to be the case, spoiler alert, but we'll save it. I don't mean to crush your hopes and dreams. We recompile, and C is 0. What? C was supposed to be 0.6, right? Well, that's because we're dealing with integers, and 3 divided by 5 doesn't divide perfectly into a whole number, right? If it divided perfectly into a whole number, then it would, of course, output that whole number. For example, we'll change this to 10. So now this says 10 divided by 5. That's obviously 2. If we implement that change, save the file, and recompile, now when we run it, we should get 2, and we do, right? Because that divides evenly into a whole number, right? But again, if we were to change this by 9 divided by 5, right, that's not going to be a whole number. It's going to be close to 2, but not quite. And so you can see when I run add, it's 2, right? But it's really not 2. We know 9 divided by 5 is really not 2, but that's what it's going to output. Now, if you wanted to use decimals, you remember from last tutorial, if you watched it, there's a float, and a float is a decimal number. And if we were to change these to float types, okay, oh shoot, float types, and int c is going to have to be a float type as well, because it's holding a float, right? And then we save it here, and we recompile, we should get the true value of 9 divided by 5. Turns out it's 1.8. Close to 2, but it's not 2, as it previously stated. So remember, floating points hold decimals, right? Integers do not. I'm going to change these back to integers and leave c as a float, and now we'll see what happens. Save. And we'll go to add, and c is 1. Okay, so as you can see, we got a little bit different behavior here. Leaving c afloat, but a and b changing to ints, it now outputs 1, right? 9 divided by 5, you know, 5 goes into 9 once, but not perfectly. Now, there is a remainder, right? And so that's where we're going to go with that next. We can actually change this back to an int, okay? And we're going to experiment with the mod sign, okay? Now the mod sign, I stated before, is simply, it's like a remainder, right? So think about what this does. If we divide 9 by 5, okay, 5 goes into 9 once, and that's it, right? Because the closest number to 9 divisible by 5 that is still less than 9 is simply 5, right? And so then we have this remainder left over, and we have a remainder of 4, right? Because the difference between 9 and 5 is 4. That's the difference between our value 9 and the closest number divisible by 5, which in this case is 5. So if we were to save this and compile yet again, and do the executable, c is 4. Okay, so it simply took the remainder of 9 divided by 5. And we'll try with some different values to just show you here. So another number not divisible perfectly by 5 would be 32, right? Well, 30 is the closest number to 32 that is divisible by 5 and still less than 32, right? And we know that 30 divided by 5 is 6. So the closest number to 32, which I said, that's divisible by 5 is 30. So the difference between 30 and 32 is 2. So now a mod b should output 2. And there it is, folks, 2. Okay. Now you might ask, what happens if we use the mod operator for a number that is perfectly divisible by 5, say 30, right? What's the remainder of 30 divided by 5? It's going to be 0 because 5 goes in perfectly, and we'll demonstrate that right now. Oops, there we go, add. It's 0, right? Because there's no remainder in a division problem where b divides perfectly into a. Okay, so that's just a simple little informational video on arithmetic operators. There are different types of operators in C++, but these are very basic ones, And they're ones that you're going to use quite a bit, typically, in the coding world, right? There's other kinds of operators, like, obviously I said the assignment operator. We've got conditional operators, right? Compare operators that compare one thing to the other, like the equal sign, okay? Comparative operator. There's also a compound assignment operator, which does an assign and an add or a plus or a minus or whatever at the same time, right? Because that would be like, well, I'll show you a compound operator really quickly. We won't even need C, right? Actually, we won't even need B, okay? Oh, sorry about that. That's my phone. Let me silence that really quick. That's very unprofessional of me. So, let's say, and we need to get that out of there. It's going to give us an error. We need to say A is 30, and let's say we want to add 2 to A and store it in A, okay? Because if we did A plus 30, right? Okay, well that's 30 plus 30, but it didn't store it anywhere. Let me change that to A as well. It didn't store it anywhere, right? If we did, if we compile it and then run it, it's going to give us 30, right? Because we added 30, but we didn't save it, okay? This is like making progress to your game, but then not saving your game. It's going to go back to simply how it was. I should use a different value besides 30 to demonstrate it equals, say, 30. This would be 34, but it doesn't save it anywhere, right? In order to save it, we would have to write A is assigned A plus 4, okay? And this is why I'm saying this is not the same as the equal sign, because in math, this just doesn't work. You know, that this is not true, right? A is not A plus 4, because A has to equal A, right? It doesn't work in math. But in computer science, since this is not the equals operator, this does in fact work. And what we're saying is A is assign the value stored in A plus 4. This is 30 plus 4, okay? And then we're saying A gets 30 plus 4, so A is now 34. So if we printed A out now, it should say 34. So let's test that theory. Here we go. 34, right? It's stored. But a compound assignment operator simplifies this code to where we could simply just say A plus equal 4, right? That's adding 4 to the value stored in A and then saving it, right? Storing it inside A, okay? And this is going to give us the exact same thing if we save and compile it. There we go, 34. Same thing, just a little bit shorter way of writing it. So that's called a compound assignment operator. And we'll go over those later. I didn't intend to add that into today's tutorial. It wasn't in the plan, but hey, you learned a little bit extra, right? So I hope you guys learned something. Learned about these operators, these basic arithmetic operators. If you have a question, make sure that you hit me up in the comment section. Try to answer everything as soon as I see it. I shouldn't have any problem answering any of your guys' questions, all right? I recommend that you follow along with these, you know, or create a code of your own so that you get the experience of typing, looking at it, because seeing and watching is one thing, but doing it while you're watching is another, and it's going to help you learn better if you're kind of following along and creating these programs along with me. Going to help you to understand it better. And if you are doing that, if you end up typing something wrong, it's going to give you an error here. For example, if we forget a semicolon on this line, on a line that needs one, some lines don't. Like, for example, this function definition here, the first line of it, does not need a semicolon. That would be incorrect, actually. And same thing with this preprocessor directive up here. You don't need a semicolon after that, right? So if we forget a semicolon on a line that needs one, it's going to give it an error, okay? I can save the file just fine, but if I go to compile it, it's not going to work too well, and it's going to tell me error, expected semicolon before return, right? Because it's like, well, this is a line here, this is the end of the line, and then we got to return, and there was no break, right? It's saying there's an error because there should be a break here at the end of this line. If we had a semicolon, save the file, and then correct that, recompile it, we're going to compile it just fine. And if you're compiling inside Notepad++ and you forget that semicolon, it's going to give you the error message, but it's going to do it down here. So, for example, if I just do F6 and then OK, as you can see, expected semicolon before return, right? And it even tells me the line. It says it happens on, says a line 11 because that's where return is on, but really it's this line here before it on line 9. But yeah, so it's very simple. Just the second video. It's going to be picking up the pace here a little bit in these next couple tutorials, but hopefully you guys are grasping the basics of C++, and if you have any questions, again, don't be afraid to ask in the comment section, and I will get back to you as soon as I can. So thank you for watching, I hope you enjoyed, and I will see you in the next tutorial.